Hello and welcome to SudoKanard. We're here to solve this exam Sudoku by Christoph Seeliger for the qualifying round of the German Sudoku Championship. So the special rule of exam Sudoku is that whenever you have a number on the outside, this number is the sum of the first few digits, and how many digits is given by the first digit here. So, for example, this 40 sum could be the sum of 7 digits. It will mean that the sum of those 7 digits is 40. So this was one of the highest pointers in the set, and there is something really remarkable, which is that all clues are on those two sides of the square, and they are here in descending order and here in ascending order. And this is very unusual for an X-sum puzzle to have clues on only two sides. I've created quite a number of X-sums myself, and I always put clues on all 4 sides of the puzzle. So let's begin. 1 can only be the sum of 1 digit. 6 could be as many as 3 digits, but we will need to put 1 and 2 here, and 1 is definitely not available. So that's 2 with a 4. So now 11 can't be the sum of 4 digits, because if you try to make 7 out of 3 more digits, they will have to be 1, 2, and 4 will repeat. So that has to be a 3. Those two sum to 8. There are a number of options to do that. On this column, I already can see that none of them is a 9, because the sum of 9 digits is 45, so that's the 9. And because the sum of all digits is 45, this 43 has to be the sum of 8 digits with a 2 on the other side. Now this is missing 5, and 5 can't be done with more than 2 digits, so only 7 is available. Those 2 digits have a sum of 5, not using the 2, they need to be 1 and 4. So here we have 4, 5, and 6. 4 and 5 are both possible for 20, but actually 4 is not possible for 29 nor for 30, because the minimum sum you can have with 4 digits starting with the 4, this is 28. So the only place for 4 is here. We have 16 in here. And deciding between 5 and 6, it's a close tie at this point. But then let's look at this. 44 can only be the sum of 8 digits with a 1 left over. 40 just like, 8 digits. So now 40 needs 5 outside. They will have to be 2 and 3, and there's a 2 on this row, and it's a sum of 7 digits. The minimum sum you can have with 5 digits is 35, so we need 6 digits for this. So here we have 6 digits summing to 37, so those 3 digits must sum to 8. There must be a 1, and by Sudoku the 1 is here. Now those will have to be 2, 5, or 3, 4, but there are already 2's in here, so they need to be 4 and 3. So this is a really quick start. On this row we still need a 1, but there's not any sum equal to 1 in here, so that's the 1. This ambiguous that. And with this 4 and this 4, we can place a 4 here just by the rules of Sudoku. Those are from 5, 6, and 9. And those here are from, well, there must be a 3, but it's not here, so that's the 3. Those are 5 and 6. And here we get 1, 8, and 9. And because of this 3, none of those 2 digits, well, what I mean by that is that 8 or 9 are too high, so we must remove them, and that's a 7. And those are from 2, 5, and 6. So here, where does 2 go? Well, all those totals are to be equal 2, so that's a 2 and a 7. We need 3, 4, and 5. 3 is not enough for this. 5 is too much for this. Minimum sum with 5 digits is 15. If I try to put a 4, then those must be 1, 2, and 5. But because of this, we don't have enough digits available. So that has to be a 3. Those must sum to 9 without using any of those, so they must be 4 and 5. This is 5 and 6. Here we need a 6, but there's a 6 there already, so that's a 6. And this is an 8, 9 pair. Here we have 2, 8, and 9. Here we have 1, 3, and 7, so this is 7, and those are 1 and 3. So now let's look at this. I think 4 here is not enough. If I try to make those as high as I can, this is 16 and we need an 8 here. Actually it works. So 4 is still an option at this point. So it seems that there's no more immediate progress with the clues. The initial progress was really something. So what do we do at this point? The missing digits here are, is it about this? Not sure. Perhaps we just need to do some Sudoku. So what needs to be done now? So those digits are from 2, 5, 8, and 9. Is that interesting? Sort of, I think. Or here, perhaps. So what is the minimum value we can have with the digits in there? So the minimum values would be with 2, 5, 2, 5 in those cells, and 8 there. That's 15. So the minimum value gives 19 with 2, 5, and 8. So we definitely need the 2 in here, and we need the 5 or 6, and an 8 or 9. So those two cells must have the smaller digits. So we absolutely need a 2 in here and a 5 or 6 with 8, or 6 here, 2 there. Oh, sorry, 2 and 5 with a 9. All right. That's some measure of progress, I guess. So this is the tricky part. So here we have only 5 different digits. And the sum of those 5 digits, 2, 5, 6, 8, 9, what is it? It is 29, believe. Is it true? 2, 5, 6, 8, 9. Sorry, 2, 5, 6, that's 13, 8, 9, that's 30. Sorry, that's 30. So the remaining digit can't be any other of them, because if I put the 5th digit of the list, then the sum is 30. So we need a digit that is not one of them, but one less than the missing digit. So if 2 is missing, then this must be a 1. 6 can't be missing, because then we would need to put a 5 here, and it would repeat. So 6 is definitely in there. Oh, I have no memory of doing this very logic when I solved the puzzle during the contest. So let me start again. If I assume that 6 is not here, then we have 2, 5, 8, and 9, which is 24, and we need a 5 here, which repeats, and this doesn't work. So we must have a 6 somewhere here, so this is not 6, and then here we get 11, so this has to be a 9. And this is 8. And that's not 8. So that is really beautiful logic. I'm not sure this is the intended logic, but I know that Christoph watches some of the videos on the channel, and I guess he watches my solves of his puzzles. So, Christoph, please tell us if this was part of the intended logic. So, the missing digit now, we remember that the digit here is 1 less than the missing digit, so it can't be, the missing digit can't be a 9 either. If I remove the 9 here, then the sum here is 21, and I need another 8. So this has to be a 9. So here this is 17, and we need another 12. And the missing digit, so we know that 6 is here, so that's so I think this will have to be a 5 after all. If I try to make this 6, then we need another 6, so we have the 2, the 1, and the 3. Actually, it works. I'm starting to think that my logic was flawed, because I was assuming that this had to be a 5. So this may be the reason why I didn't do this logic, because I assumed something I'm definitely not certain of. So I was making the sum with 5 digits where it could be of 6 digits. So this was incorrect logic. So, well, that's unfortunate. So perhaps the logic is around here. Could this be a 2? Well, it definitely could. Or perhaps, could this be a 6? If this is a 6, then we must have 15 in here. But how do we do 15? Actually, I can't do 15 with 3, 5, and 7. So this totally works. But if I put a 5 in here, then those 4 digits must sum to 15. And this is where it gets spicy, because the smallest digits available are 2, 3, 6, and 7, which makes 18. So this is not a 5, it has to be a 6. Oh, and then, knowing that this is a 5, my former logic becomes valid. Well, let's just get back to this. So perhaps the logic I did earlier, which in hindsight becomes valid, well, perhaps it's just not needed, because we'll start with this. So those 3 digits must sum to 15, and the only way with the digits available is with 3, 5, and 7. So that's a 7. This is 3 and 5. This is 9. This is 5. Here I need 2 and 8. Here I need 8 by Sudoku. This is 6 and 9. This is 6 and 9 as well. And this is 5 and 7. So now, the logic is just that if I try to put a 2 here, then this is a 2, 8, 9, 4. We have 7 plus 17, that's 24, and we need to repeat the 5. So this is much less complex logic than what I did earlier. So 2 doesn't work here. So here we have 11, so this becomes a 9, that's 8. Here we have 19, so this plus that must be 10, so that's 9, that's 1. And now the rest of it should be more or less straightforward, or well, maybe not that straightforward. Let's just do some Sudoku. We still need 2, 3, 4, and 7, so this can only be a 2. 3 or 7, 3 or 4, 3, 4, 7. This column needs a 1, it can only go here. This is from 6 and 9. This row still needs 2, 6, 7, 8. So this is from 6, 7, 8. I said 2, but it was a 3 actually. 3, 6, 7, 8. 3, 6, 8. 3, 7, 8. Well, nothing so special. So I will need to address those exam clues. So does 4 go? Does 4 work? Sorry. With 4 and 3, that's 7. I need another 17. So it will need 8 and 9. And this seems to work. Does 4 work here? This doesn't work. So we have 5, we need another 12 with 2 digits. 8 here would repeat the 4, 2 wouldn't just not work, and 9 here would repeat the 3 on this row. And this is definitely some logic I did, I remember that. So this is 4, this is 5, we get 5 and 7 at the bottom, and this 7 here, and the 7 on this row is here. So 4 and 3, the missing digits are 8 and 9, so that's 8, that's 9, that's 2, that's 8, that's 2, and the rest should probably be just single digits eliminations. 3, 4, and 6, oh, actually, so here we have 8, we need another 9, so they will be 6 and 3, that's 4, that's 3, and the rest probably doesn't need to be explained. 3, 5 here, 9 there, 4 there, and this is correct. So I probably took much longer than during the contest because I wasted some time working on an assumption that was in hindsight correct, but had no place in the logic at this point. The real logic was about this row, that 5 or 6, well, 5 and 6 were not both possible. 5 had to be eliminated from here because of the digits available. So really impressive construction by Christoph, and I just love exams. Thanks for watching this video and see you soon on SudoKanard.